And we'll go from current slide. And I'll try to minimize the amount of time I spend on announcements. If you or someone you know was in a first mini-term course, they finally got the first mini-term course, student course, whatever you call it, evaluations done. So the surveys are open. So if you or someone else you know is in a first mini-term course, please do the student course evaluation. Those are very, very important to us. Okay. Number 2, of course, I'll be leaving at 9 o'clock. I've got a doctor's appointment, so I'll be leaving at 9, so splitting very shortly. I'll be back, I'm hoping before 12, but if it's not before 12, somewhere around 12. But then I'll be here the rest of the day, pretty much. I've got to go off campus one more time right before around 1 o'clock or so, although that's going to be very short. But then I'll be here the rest of the day. Thursday, absolutely no classes. I will be in Tuscaloosa already I'll be on my way to Tuscaloosa. Well, no, I'll be in Tuscaloosa by now. Normally when I get here at 8 o'clock, so I'll be on my way by 8, and should be there by now. So I will be out of pocket until probably sometime around 4:30 or so. I plan to, when the meeting's over, I'll come back, drive right by here, I'll pull in and take care of stuff then. So I'll be here till 6 on Thursday.
We don't come to class Thursday?
Yes, there's no, wait. Yeah. I'm not here, okay. But your test is Thursday. Right. Yeah, I won't be here, but your test will be Thursday. Dr. Thomas will be administering it. It's all run off. The graph paper's done. But if you'd like to bring your own, bring it. Bring scratch paper, because I do look at scratch work to see if you got something right on scratch work, but copied it wrong on the test. So, and you can have your formula and equation sheet. I've already told Dr. Thomas that, and I'll tell her again, that it's perfectly permissible for you to have a formula and equation sheet. Bring your own calculators and know how to use them, okay? Because that's, I don't have any to provide, and those that I would, you probably would need some instruction on how to do it. So please bring your own calculator. You won't absolutely have to have one, but it will speed things up. And here's Jay. All right. And here's Olivia. All right. Any questions before we get going? 5 people here. You got them in the book. Okay. Any questions? Especially about chapter 1. Okay? This chapter 2 stuff is still pertinent to what you did in chapter 1. And where we're beginning today is in chapter 2, polynomial and rational functions. So we're in the polynomial part. 2.1 is quadratic functions and models, and this is the definition of a polynomial function. Polynomial function on page 114, near the top of the page. Now, polynomial. We're not into quadratics yet. This is a special kind of polynomial function. So, if n is any non-negative integer, okay? Non-negative integer. What? Huh? Gotcha, got it. If n is any non-negative integer, okay, what does that mean? Integers are the counting numbers, right? Non-negative integers would be the counting numbers. Naderia is here. Okay? With 0. 0 also would count. Okay? N be any non-negative integer, 0, 1, 2, 3, 4, 5, 6, and on. No fractions, no decimals, no negatives. Okay? Now, the A's that we have here, A sub n minus 1, all the way down to A sub 2, A sub 1, A sub 0, okay? Those are any real numbers. They can be positive or negative, fractions or decimals, rational or irrational, just any real number. as long as that a sub n, the very first one, is not 0. The rest of them, they could be 0. No problem there, but the first one can't be 0. Then here's a function, f of x is equal to some real number, not 0, times x to the nth power, n being an integer, a counting number, okay, whole number, a sub n minus 1, that's another real number, plus this, x to the n minus 1, plus now. The subscripts here of the a's, they're just counters. They just let you know this is the coefficient that goes with that exponent. This is the coefficient that goes with that exponent. This is the coefficient that goes with that exponent. They're just there as markers, okay? The n's up here as the superscripts, those are important. This is x raised to the nth power, x to the n minus 1 power, x to the squared, x to the first, x to the 0. Well, you don't even see that. X to the 0 is 1, okay? Those are important n's up here. These are just markers here that say this is the coefficient that goes with that exponent, okay? But this is called a polynomial function of x with degree n, okay? Now, why could this a sub n not be 0? Well, if a sub n was 0, then this term doesn't exist. Then that would be a polynomial function of degree n minus 1. So for this to be of degree n, a sub n cannot be 0. That's the only reason it can't be, okay? Polynomial functions are classified by degree, okay? This is an nth degree polynomial, okay? For instance, a constant function, what is the degree of that? 0, because it's x to the 0th power, which of course is 1. So that's just a constant, okay? Now they say as long as c is not 0, okay? Now there is a technical reason for that. It's not, Keelan is here. It's not crucial at this stage, but they do like to say c can't be 0. Okay, so anytime f of x is equal to c, whether c is positive, negative, fraction, decimal, rational, irrational, it doesn't matter, that is considered to be a polynomial function of degree 0, okay? The linear function, what degree would that be? 1, because the exponent is 1, okay? Now, of course, a couldn't be 0, because if a was 0, that would be a constant function again, degree 0. In this section, we're studying second degree polynomial functions. That's the ones that look like this, right there. They don't have the higher degrees on them. They just look like that, which are called quadratic functions. I don't know why they're called quadratic functions, okay? Because usually to me, quad means 4, okay? And these don't have 4 anything, unless when they factor, it's a binomial times a binomial, and that looks like 4 there. But that's a silly reason to call it a quadratic function. I have no idea why they call it quadratic, but they do, and it's always been that. So, can't change it. For instance, each of these, they say, is a quadratic function. Is this? Maximum degree of 2. Yes, that's a quadratic function. How about this one? The x only has a 1 by it. And you don't have to see that. This is squared. So if you squared this, that'd be x squared plus 2x plus 1. So that would be, and then you multiply it by 2, 2x squared. So that would be quadratic. How about this with the fractional x coefficient? Would that still be quadratic? Sure, any real number could be a coefficient. The exponent can only be whole numbers, okay? And that's the quadratic. Can you have a negative coefficient? Sure, no problem there. Any real number as long as the exponent is 2. How about this? I don't see a 2 anywhere as an exponent. Oh, but when you FOIL it, x times x is x squared. That's the maximum exponent. Sure enough, that's also quadratic. Notice the squaring function is the simplest quadratic function. It has degree 2. That would be h of x is equal to x squared. I mean, that's as simple as you can get and be a quadratic function. The parent function of all quadratic functions. Any questions on that? Okay? So here's the definition of a quadratic function. Let A, B, and C be any real numbers. Now, earlier we were calling it A sub 1, A sub n, A sub n minus 1. Here we're just calling them A, B, and C. Any real numbers. And here's Tucker. Okay. A, B, and C are any three real numbers, as long as A is not 0, because if A was 0, that wouldn't be a quadratic function, would it? It'd be a linear function. The function f of x is equal to ax squared plus bx plus c is a quadratic function. Okay? Maximum exponent 2. And all the exponents have to be whole numbers. The graph of a quadratic function is a special kind of U-shaped curve. Anyone knows what it's called? Parabola, exactly. U-shaped curve. I don't like calling it a U-shaped curve because in U's, the limbs go straight up. In quadratic, in parabolas, they don't. They're always moving out. Okay? But what they mean by U-shaped, they're rounded at the bottom. Okay? Parabolas are always, they're never pointed at the bottom, they're always rounded. So that's why they call it U-shaped curve. Parabolas occur in many real-life applications, especially those involving reflective properties of satellite dishes and flashlight reflections and things like that, reflectors and things like that. Y'all see the dish TV or direct TV, those discs, those are parabolic shapes. Okay? And here's why. You don't need to know this for what we're doing here, but just for general information. A parabola always, if parallel rays are coming into a parabola, they always reflect to a single point called the focus. And that's where, on those discs that you see, there's that receiver sitting out here, that's on the focus. So all the signals coming from the satellite are coming, hitting there, and focusing on that, and that's why you pick up the big signal. Okay? Now, flashlight reflectors, you know that sort of silvery looking metal that's behind the bulb. The bulb is on the focus, and the light coming off of it hits the parabola, and that sends it off parallel. And that's why your flashlight has a parallel beam of light coming out of it. And here's that. All right. Also, the lens behind your headlamp in the mirror in your car. Okay? Notice that's a curved shape, parabolic shape. Why? Because the bulb is sitting on the focus, it hits the mirror and goes out pretty close to parallel. Okay? Now, why do I say pretty close? Because the bulb is not a fixed point, it's finite. So it has some refraction that goes on, but most of it goes out pretty much parallel. Okay. So you run into parallel shapes all the time. Have any of you ever thrown a ball or hit a ball? It follows a parabolic shape. Okay. Except in basketball, a dunk. And I've never done that. Okay. Never come close. Okay. That would be the only one that's not parabolic. Anything that goes up and then comes down, parabolic. We run into those all the time. Hit a golf ball, parabolic shape. Okay? Whatever. Even a fastball in baseball is still going to be curving down slightly. Okay? Here's the baseball factory. You can tell us about it. Okay? So everything you throw or hit is going to be, now a grounder won't be parabolic. Okay? Now, all parabolas are symmetric with respect to a line called the axis of symmetry, good name for it, or simply the axis of the parabola. The point where that axis intersects the parabola is called the vertex of the parabola, okay? So here's a parabola that's opening upward, okay? And this has some generic form, ax squared plus bx plus c, as long as this a is not just, it's not equal to 0, this one's greater than 0, okay? Now, how do you know that? Because the parabola is opening upward. Because when you increase x's and a is positive, this thing is going to go really large really quickly. So that's opening upward. the axis is this right down the middle of that parabola, and the lowest point here is the vertex, where the axis intersects the parabola. And you see everything on this side is mirrored on that side. Okay? So if the leading coefficient is positive, these open upward. A leading coefficient means the coefficient A of the maximum exponent term, the squared term. But if that A is negative, remember A can't be 0, or else it won't be a parabola. Okay, but if A is negative, that means it's opening down. Why? Because x squared is always positive. No matter what x you put in there, that's going to be positive or 0. Okay, it could be 0, but it's never going to be negative. But if the A is negative, that means it's dragging it down. So if the leading coefficient is negative, that means it's opening downward. And again, if you draw that line, the axis of symmetry through the center of the parabola, now it's the highest point is going to be your vertex. So your vertex is either the lowest point if A is positive, the highest point if A is negative. Okay? That leading coefficient is negative. Does that make sense? Lots of information here about a parabola, just by looking at it, just by studying the A's. However, the B's and C's don't tell you much. C tells you one piece of information, and that's the y-intercept. Because if A is equal to 0, the y is equal to C. 0C is going to be your y-intercept. That would be it here. It would be somewhere up here on that one. Okay? It's the only thing C tells you. That's not very much. Okay? A tells you whether it opens up or down. That's a little bit, and that's good information to know, depending on whether A is positive or negative. So, that B hardly tells you anything. So maybe there's a better way to express this quadratic function. Well, let's go on. And this is repeating what we were just saying. When the leading coefficient is positive, the A is positive, the graph of this always opens upward. When the leading coefficient is negative, it always opens downward. How about if the leading coefficient is 0? It can't be 0. It wouldn't be a quadratic function then, right? If that was 0, it's a linear function. Trick question. Okay. All right. And both of these, as long as A is not 0, this is a parabola that opens either upward or down. Okay? The simplest type of quadratic function, this isn't quite, okay? Almost simplest type is this one. The simplest type would just be f of x equal x squared, the square root function. If you put an A in front of it, it's pretty simple still. Now this could open up if A is positive, down if it's negative. But the magnitude of A, how big A is, also influences that parabola. If A is really large, it's opened really tight. It really shoots up fast. If A is really large negative, it really is tight going down. But if A is, say, between 0 and 1, it takes a long time to go up or to go down. So the magnitude of A is also important. The sign tells you which direction it opens. The magnitude tells you how fast it goes up or down. Okay. Its graph is a parabola whose vertex, this is the one that's ax squared. The vertex is always the origin. Because when x is 0, y is 0. Okay? So 0, 0 is on the parabola, and it's also your vertex. Okay? And when A is greater than 0, this is a minimum. When A is less than 0, that's a maximum. Okay. All right. So already we know a lot about parabolas just by knowing that value for A. And if there are any other things. Like I said, if C was 0, your y-intercept is 0. And sure enough it is. Okay. Now, when you're sketching the graph of a simple quadratic function like this, it's helpful to use y is equal to x squared, your parent function, as a reference. Because we know how that goes, right? 0, 0, 1, 1, negative 1, 1, 2, 4, 4, negative 2, 4, 3, 9, negative 3, 9. Yeah, you know how it goes. And that's your parabola. Okay? We know how that goes. That's your reference. Okay? So let's do that to this one. Okay? Sketch the graph of each quadratic function. Compare it with the graph of y is equal to f x squared. So let me get my pen set up. Okay. Now, I do need to ask you all to keep track of time. When we get close to 9 o'clock, let me know. Okay? Because I've got to leave at 9 for my doctor's appointment. Sorry about that. Cheating you out of part of your tuition dollars, but there'll be no refund. Sorry. Okay. So, but you can still watch whatever we do next on a YouTube video from last term. Okay, so you can watch that. So let's first do your graph. Now, I'm going to cheat a little bit. I'm going to look at these A's here. First, what's the A here? 1. What's the A here? 1/3. 2. What do all those have in common? They're all positive. So therefore, I know this parabola is not opening downward. It's opening upward. So I'm going to draw my x-axis down here because I can do that. Okay? There's my x-axis. I'm not going anywhere negative with it. So let's tick off a few points. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7. Ooh, that messed up, didn't it? Why won't that mark? Okay, something like that. We aren't going to use them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let's start with y is equal to x squared. Give me some points on it. I just gave them to you a little bit ago. You give them back to me. Okay? Christian, huh? Oh, no, right, sorry. Cordero. Okay. Thought it was a C word, but I had the wrong one. Okay. Okay, has anyone else come in while I was yakking at the flapping my guns up there? Okay, I think not. Okay. Sorry about this, but you do know I'm leaving at 9, right? Okay, all right, glad you're here though. Okay. So, give me some points that are on this graph. Y is equal to x squared. Give me an x. Second, 1. And what would your y be? 1. Okay. Huh? One more time, I hear that. James. Yeah, okay. James Waters, right? Okay. No, I'm sorry, James Webb. Can't read my writing. Okay. I don't know if you knew this or not. I'm leaving at 9 this morning. I have a doctor's appointment. Okay. All right. So when x is 1, y is 1. Give me another x. 0. What's y? 0. Give me another x. 2. What's your y? Say again? 4, because when you square 2, you get 4. So that's up here. So there's that one. Give me another x. 3. When you square 3, what you get? Up here. Don't think we can go anywhere else positively. Hint. Like a politician, go negative. No, I'm just sorry. Okay. And by the way, speaking of which, what is today? Second? Go vote. Absolutely. This is primary day. Do not ever let a day when the polls are open pass you by. Vote every chance you get. It's not only your right, it's your responsibility. Because guess what? Here in Alabama, sometimes we have elections that less than 50% of the eligible voters get out there and vote. So you know what that means? The winner could have right around a quarter of the people in his favor or her favor. That's not a democracy. So please, folks, vote. If you need to, do a quick run through of who the candidates are and whether you like them or not, but vote. Please vote today. I'm going to vote on my way home this evening. I get off here at 6. I'm driving right to the polling station and vote. It's open 7 till 7. So please go vote. Okay. Paid political announcement. Okay. Next. Give me another X. -1. And what would that be when you square it? +1. Okay. Give me another X. -2. What happens to that when you square it? 4. Okay. Give me another X. Second. -6. 3. Okay. I like that better. And that would give you a +9. There you go. What do we have? We have a parabola that comes down to always make them smooth and rounded at the bottom, never pointed, and goes back up. What's the vertex of that one? The vertex is the line x equals 0. You're right. No, I'm sorry. I was saying that. I meant to say axis of symmetry. Yeah, the vertex is 0, 0. You're absolutely right. Okay? And fully. Latrissa. Okay. And do you know I'm leaving at 9? Okay. Sorry. How much time do I have? Huh? 7 minutes. Okay. Glad you're here for the 7 minutes. But I want everybody to realize this too. Even though I won't be here Thursday, you will be having the test on Chapter 1 on Thursday. Dr. Thomas will be administering it, and that will be here. Please bring with you your formula and equation sheets. She knows you're going to have those. Scratch paper. If you want to use your own graph paper, bring it. If you don't mind using my old cruddy stuff, you can use that too. That'll be available. And calculator, I'll say that. Bring your own calculator so you'll know how to use it. You know, there's not time in a test to say, how do you get this done? You know, so you don't have to have it. Everything you can do without a calculator, but it might speed you up some and give you a little confidence. Okay. So this is your parent function, your y is equal to x squared. Let's do f, but I need a different color for f. Someone pick a color. Second. Green. Green, green, it's green, they say, on the far side of the hill. Okay. How do we do this one? We don't have to go back and read. Well, you tell me. Give me an x. Second. 1, okay? Now before, when an x squared is going to be 1, right? But take a third of that, and that's going to be down here at 1/3. Okay? Give me another x. 2, that would be up here at 4. A third of 4 would be 4/3, which would be 1 1/3. That would be right here. Give me another x. 3. 3 squared would be 9, but a third of 9 is 3. So that would be right here. And actually, you can do some more if you want to. What's 4 squared? 16. And a third of 16 is 16/3, which is 5, 1, 2, 3, 4, 5 1/3. That would be out here. Okay? You can do another one. 6, is that right? 1, 2, 3, 4. Yeah. 6 squared would be, help me, 36, right? And a third of 36 is 12. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we can't do that one. But here's what you got here. Whoops, I'm not following my dots too well, but somewhere like that. How about on the negative side? Oh, I forgot to do 5, didn't I? Okay. 1, 2, 3, 4, 5. What's 5 squared? 25, and 25/3 would be 8 1/3. 1, 2, 3, 4, 5, 6, 7, 8 1/3. That would be right here. Okay? I knew there had to be another point in there. And 6 would be 12. That would be off scale. How about negatives? Just like on the other side. That's what the axis of symmetry is. Oh, I never asked that, was it? What's the axis of symmetry of that person? X equals 0. It's whatever the x component of the vertex is, 0, 0, x equals 0, that would be the line, the vertical line that goes through that. Okay? And this would be 1/3 of that, 1/3 of that one, 1/3 of that, 1/3 of, well, it's just, guess what? It's symmetric. 1, 2, 3, 4, 5 1/3. That would be over here. And then this one would be, whatever that was, 8 1/3. 1, 2, 3. 8 1/3 would be right here. So it would be like that. My curves are not very good. They don't go through. They don't connect the dots very well. But you see what happened? An elephant sat on it. Oh, no, well, I mean, it got a vertical shrink because your coefficient was less than 1. Right? So let's do this one. G of x is equal to 2x squared. I'll need a different color. Give me a color. Somebody. Blue, Carolina, or dark? Dark, okay. Okay. Somebody doesn't like Carolina. Okay, never mind. So what do we do with that? X equals 0, still 0. But when x is equal to 1, x squared is 1, but 2 times 1 is 2. So it's here. Minus 1 would still be 2. 2 would be 4. Double 4 and you get 8. 4, 5, 6, 7, 8. That would be here. Okay? And negative 2 would also be 8. You can't go any further because you get off scale really fast there. Here's what you got. Every point on the parent function is doubled. Every one is doubled. 0 doubled is 0, 1 doubled is 2, 4 doubled is 8, 1 doubled is 2, yeah, all the way. So there's your other one. This one, I don't know. When I was young, I remember these toys. I don't think they make them anymore, but maybe they do. They had something, and if you pulled it, the arms went up. Did you ever see those? Pulled the string and the arms went up, or something happened like that. That's what you've done here. It's a vertical stretch. You pulled the string and the whole function went up. Okay? It closed in on you. That's a vertical stretch because your A is greater than 1. A between 0 and 1, vertical shrink. The elephant sat on that. Okay? So those are these two functions. How are we doing on time? 9 o'clock. Sorry about that, folks. Looks like we're going to have to go. Let's see. Let's just see how they did theirs. We don't want to just trust my ugly drawing, okay? Here is the parent function. The gray one is the parent function. Y is equal to x squared. 1/3 x squared is the one the elephant sat on. It's really compressed, okay? And the 1, 2x squared, vertical stretch. So one pulled the string and the limbs went up. Okay? Yes? Okay. I wish I could. You can come see your scores, but not everybody's turned it in. Now this class is probably the best I've had in years about turning in the first quiz, but I'm still missing 1, 2, 3, 4, 5, 6 out of 29. That's not bad. Okay? But I can't return them. But you can come see them if you want to. Anyone want to come see your quiz? Huh? I want you to be sure you don't make the same mistakes on the test. Anyone need to see it? Anybody? I'll be glad to show it to you. Okay, if you don't. All right. And if anyone hasn't turned in the quiz, please get it in. Okay. Now, I do take that back. I think I said 6. 2 more people turned it in last time, and my work-study student marked them, but I haven't. No, she didn't. I didn't give them to her. I'll be grading those while I'm in the waiting room. So, but I won't have those for you to see Well, those people aren't here anyway, I don't think. All right, so Thursday, be here, be on time, and get your test done. Now, if you can't finish the test, do as much as you possibly can, but you can write not finished at the top. I'll grade what you do so far, but then the rest of them you'll have a chance to come back. So just come see me. Now, Friday I'll be on the Birmingham West campus, but Monday, Tuesday, Wednesday, Thursday, next week I'll be back on this campus. Okay. All right. Sorry I have to leave early today, folks. Bad news. Okay.
I did my quiz, but I don't know we have to keep the scratch paper. So do you want me to rework it and bring it on Thursday, or just give it to you?
Okay.
I don't have my scratch paper,
Well,
but I can rework it.
yeah, well, grade what you got. If you want to bring it, I won't be here Thursday, but you can bring it Tuesday, and if it affects your grade any more, you can change that. I forgot to tell people if they didn't turn in the quiz, I've already said it before, then that basically is asking for me to do a 0 on the quiz. I don't want to do that. But I've recorded that here. Okay. So let me shut down the recording.